Welcome back, everyone. We are continuing Unit 3B on bonding. In this lesson, we will focus on intermolecular forces. We will discuss the following intermolecular forces by completing practice problems. Intermolecular forces are the forces that happen between molecules. So in this example, I'm going to circle two water molecules, and the intermolecular forces between these two water molecules are represented by this dashed black line. Now we have something called intramolecular forces that are the forces that happen within a molecule. An example of this would be this hydrogen bonded to this oxygen. So once again, it happens within a molecule. Our first question. State in terms of strength of intermolecular forces why iodine has a higher boiling point than F2, than fluorine. In terms of polarity, these are both nonpolar molecules. So if we're talking about the intermolecular forces that happen between nonpolar molecules, the intermolecular force that we're talking about is London dispersion forces. In London dispersion forces, the atom that has more electrons is the stronger force. So if we're comparing iodine and fluorine, the way to answer this is by taking out a periodic table and looking at how many electrons each has. Fluorine has 9, while iodine has 53. Now, to answer this, we can say, well, iodine and fluorine are nonpolar molecules. The intermolecular forces that happen between nonpolar molecules are London dispersion forces. The more electrons the atom has, the stronger the dispersion forces. So in this case, iodine has more electrons than fluorine. Now going to number 2. Number 2, identify a type of strong intermolecular force that exists between water molecules but does not exist between carbon dioxide. So the one that exists between water molecules. That intermolecular force is called hydrogen bonding. Now, we did see a picture of a water molecule experiencing intermolecular forces with another water molecule. That intermolecular force is called hydrogen bonding. And the reason it's called hydrogen bonding is because the hydrogen in one molecule is being attracted to an oxygen in another molecule. Now, hydrogen bonds are not an actual bond, it's actual attraction. So it's happening between molecules. It occurs between a hydrogen of one molecule and a fluorine, oxygen, or a nitrogen in another molecule. Moving on. Explain in terms of strength of intermolecular forces why the boiling point of diethyl ether at standard pressure is lower than the boiling point of water at standard pressure. So we just discussed the intermolecular forces that happen between water molecules, and that's hydrogen bonding. And we mentioned that it's the strongest intermolecular force we have. So water has a higher boiling point because it has hydrogen bonds between water molecules. We took a look at this picture and we saw that the intermolecular forces are hydrogen bonds between the water molecules. Another thing, hydrogen bonds occur between a hydrogen of one molecule and a fluorine, oxygen, or a nitrogen in another. Now, if you're thinking, well, okay, this one has an oxygen, why aren't we counting that as a hydrogen bond? This is not going to experience hydrogen bonds. This molecule will not experience hydrogen bonds. And the reason for that is because a hydrogen needs to be attached to a fluorine, an oxygen, or a nitrogen in order to experience hydrogen bonds with another molecule. So in this instance, the oxygen is not connected to to a hydrogen. It's connected to a carbon and another carbon, so it will not experience hydrogen bonds. This hydrogen is connected to an oxygen. This oxygen is connected to this hydrogen. So it permits for this hydrogen bond to happen. Let's move on to number 4. Explain why NH3 has stronger intermolecular forces of attraction than Cl2. Once again, if an atom is bonded to itself, automatically a nonpolar molecule. So if we take a look at these two, we have, let me just clear this, we have hydrogen bonds happening between NH3 molecules. So here we have one NH3 molecule and another NH3 molecule. The hydrogen bond is happening between the molecules. This N from this one molecule is being attracted to this H from this other molecule. So once again, a hydrogen bond is not an actual bond, it's an attraction. And now for Cl2, well, it's a non-polar covalent bond. So we're not talking about hydrogen bonds here. We know that hydrogen bonds are the strongest intermolecular force that we know. And for this, we have the weakest intermolecular force. So Cl2 is experiencing dispersion forces between two molecules or more. And then here, between NH3 molecules, we have hydrogen bonds. Moving on. Compared to H2S, the higher boiling point of H2O is due to the, once again, we already know what type of intermolecular forces are happening between water molecules, and that's hydrogen bonding. So it's in result to stronger hydrogen bonding in water. Number 6, which type of attraction can be used to explain the unusually high boiling point of H2O? Hydrogen bonding. Moving on. Hydrogen bonding is a type of, we know this, it's between molecules. So this is a strong intermolecular force. Number 8, which term represents an intermolecular force in a sample of water? Hydrogen bonding. Number 9, what happens when NaCl, solid, is dissolved in water? So here we have a picture of Na and Cl. So Na we know is the cation and Cl is the anion. So the green circles that you see with a negative inside of it, that represents chlorine. And the gray with a plus sign inside of it, that represents sodium. When it starts to dissolve in water, they separate. So here we see that they are starting to separate into individual ions. And now we see them completely separated. So here we have the chlorine and the sodium ions spaced out. So now we're talking about a chloride, and the name of the metal doesn't change, so this is sodium. So we have a sodium ion, and a chloride ion. So which of these happen? If we look at the multiple choice, the only one that matches to the picture that we have to the right is B. Sodium ions are attracted or attached to the oxygen atoms of water molecules. Take a look at this box. This is Na. plus 1, and it's being attracted to the oxygen. So these white sides that you see, that's hydrogen. So 2 hydrogens and 1 oxygen. Moving on to number 10. Which statement explains why bromine is a liquid at STP and iodine is a solid at STP? Once again, anything bonded to itself is a nonpolar molecule. So these are both diatomics. If we're talking about nonpolar molecules, we're going to look at the number of electrons each one has, because we're talking about London dispersion forces as the intermolecular force. So the more electrons, the stronger the dispersion forces. So here we have iodine with more electrons, and D is our answer. Molecules of iodine have stronger intermolecular forces than molecules of bromine. Moving on. Number 11. Which diagram best illustrates the ion molecule attraction that occurs when the ions of NaCl are added to water? At this point, we already saw a picture illustrating what happens when NaCl is dissolved in water. So the answer is A. Number 12. The strongest van der Waals forces. This is also referred to London dispersion forces. So there's 2 names for the same intermolecular force we're talking about. Of attraction exists between molecules of. We got to look at each one of these on the periodic table, because if we're talking about anything bonded to itself, nonpolar molecule. So if we're talking about the intermolecular forces that happen between nonpolar molecules, we're talking about dispersion forces. The one that has the greatest number of electrons is the one that has the greatest force. So in this case, that would be iodine with 53 electrons. Number 13. Explain in terms of intermolecular forces the difference in the boiling point of O2 and O3 at standard pressure. Now, I want you to notice how I skipped this whole passage of reading. Many questions give a lot of information that you will not need for your answer. So I went straight to the question. Now, O2 and O3, they both have oxygen, but if we're talking about in terms of intermolecular forces, the difference in boiling points happen because of how they are made up of. So one is made up of 2 oxygen, the other one is made up of 3 oxygens. The one that is heavier will have a higher boiling point. So ozone is a heavier molecule than oxygen and has a stronger intermolecular force. So if they have stronger intermolecular forces, then the boiling point is going to be higher. Now there is another way to explain this. So this is one way. You can say ozone, O3, is a heavier molecule than oxygen, O2, and has stronger intermolecular forces. Another way you can explain this is by drawing the molecules out. Ozone is a polar molecule. It has a bent molecular geometry. It looks like an upside down V. So it has a positive pole and a negative pole. So it's a polar molecule. If you start chopping it up down, vertically, etc., it's a polar molecule. O2, on the other hand, oxygen is a nonpolar molecule. If you start chopping it up, you will have symmetry all around. So this is another way to explain the difference in boiling points. At this point, we are at the end of this video. I hope you found this helpful. Until next time.